Okay, so this is 6.4 data analysis. And firstly, for 6.1's group data, this group data shows how player height, shown by figure 1, links to how many rebounds are made, which is figure 2. And figure 2 is a scatter graph, and these graphs are usually used to show a correlation. A correlation can tell you the relationship between two variables, for example, the height of the player compared with the amount of rebounds shown above. The correlation can be positive or negative. This is determined by the R value. The R value correlation coefficient is calculated between -1 and 1. Figure 3 has worked out the correlation values, and this is through Pearson's rank correlation coefficient test, which measures the linear correlation, giving a value between 1 and -1, where 1 is total positive correlation and 0 has no correlation. Basically, what these graphs show, figure 1 shows the player height between the whole group and the one next to it, with the offense shows the rebounds made offensively. You see that the highest was made, but it was 2. So figure 2 shows the correlation between player height and offensive rebounds, and the correlation is positive, and so that means that the player, the bigger the height is of the player, the more rebounds the player should make. 6.1 performance criteria. What's on the screen is the movement schematics of Aaron Sparrowhawk and Charlie Inkpen, who we are analysing. And movement schematics show us where the performer has been during their performance. The above schematics are from the main players, Aaron and Charlie. And from Aaron's schematic, you can see that he spends a lot of time in the 2-point area, which may suggest that Aaron is more effective when attacking. He also uses nearly the entirety of the court, which suggests to us that he's hard-working and moves around a lot. Charlie's schematic shows that he doesn't spend as much time in the 2-point area as Aaron, meaning he may not be as effective at scoring, and he also doesn't seem to use one side of the court. This may be because he is more comfortable dribbling with one hand, and he keeps the ball away from the centre of the court and ultimately away from the opposition. This bar graph shows that Aaron has in fact covered more distance than Charlie, 50 more meters, which is about twice the length of the court. The court is around 28 meters, so that means he's gone up and down the court around twice more than Charlie. This means that Aaron has more chance of getting at more rebounds and more shots than Charlie. They also have both been covering more than the average distance, however, which shows that they are both hard working and willing to run around and make plays for their team. This shows the free throws attempted. Figure 1 shows that Aaron had attempted 4 free throws compared to Charlie's attempted 2. Out of Aaron's attempted 4, he only managed a 50% accuracy rating by scoring 2. Charlie, however, also scored 50 by scoring 1 out of his 2 shots. This suggests that Aaron and Charlie both are as accurate as each other, but Aaron is better at making players foul him, but maybe moving the ball quickly and putting himself in the positions where the opposition have no choice to foul, because the fouls equal these free throws. This is how it would make sense that taller players are better at layups, because they're closer to the end, so they have a better reach to get the ball up into the net, to the basket. However, from our information collected from the game, Charlie, who is 180 centimeters tall, 7 centimeters taller than Aaron, managed to attempt and make one of his layups, which was the same as Aaron. You would have thought that Charlie, who is taller, would have managed to get more layups, or at least attempt more. They also both managed to get 100% layup accuracy, meaning that the layup may be their strongest shot technique, but because they only managed one apiece, it's not really enough evidence to say it's accurate enough. 2-point shots. Aaron attempted 5, 3 more than Charlie, who attempted 2. Out of these 5 attempts, Aaron made the 2 shots, which is less than half, meaning achieved an accuracy potential of 40%. Charlie, out of his 2 attempts, managed to score both of them, meaning that he gained an accuracy of 100%. This suggests that Charlie is more accurate than Aaron with his 2-point shooting. However, as Aaron attempted 5, it means that he's maybe better at making the space to shoot, or it may suggest, as he missed 3, that he rushes his shots. Aaron and Charlie are, however, scoring and attempting more 2 points than the average, which shows how they are vitally contributing to their team performance with points to ultimately win the game. 6.2 now. 2 videos on the screen from Aaron and Charlie. I'll just play them. So Charlie's box out. The figure 1 shows that Charlie has marked his man. He's made contact with him, which is important so that Charlie now knows where his opponent is when he turns his back to watch and collect the ball. Figure 2 then shows Charlie facing the basket and waiting for the ball to drop. He hasn't got very low to stabilise his centre of gravity, which is important, otherwise his opponent will topple him and intercept the rebound. He stays up due to the fact that he has put his weight up against his opponent, but if they move back, then Charlie will obviously fall backwards. Figure 3 then shows that Charlie has watched the ball bounce, still holding off his man. It is good that Charlie has watched the ball drop and then collected it, as if he tried to receive the ball without the bounce. It may have slipped through his hands as it's coming at speed with the gravity. The bounce decelerates the ball. Figure 4 shows then that Charlie has turned his head to see where his man is whilst he shields the ball away from his opponent. This is important as they may steal the ball if he doesn't look where the opponents are. However, he doesn't pivot with his elbows, which usually creates more space because it warns the attackers off, as they don't want to get hit by the flying elbows. Figure 5 then shows that he's given off the ball successfully. So for Aaron, figure 1 shows that he's made the contact with his man. He knows where he is and he can't get past him. He then changes into figure 2 where he's got down lower to spread his body weight and keep himself upright and steady so his opponent doesn't topple over him. He's also now facing the ball to judge when he will move to collect it. Figure 3 then shows that Aaron has jumped, still in front of his opponent with his hands to create a target for the ball. He hasn't followed the perfect model of letting it bounce, but has successfully retrieved the ball. However, the pace of the ball could cause Aaron to drop it next time. Figure 4, Aaron pivoted. Just like the perfect model, you can see that his elbows are out, like making space for himself and scaring off the opponent so he can pass the ball off. 6.3 then for numerical analysis. The R value is 0.89, which means that the correlation is positive between impulse and the jump height. So this means that the bigger the impulse, the bigger the jump height. The p-value of this finding, which is 0.000017, is below 0.05, which shows that the finding is significant and there is meaning to how a bigger impulse will increase the jump height. The scatter graph in the next slide will show how the correlation is between these two. So you can see the relationship, and the graph gives evidence that backs up the table in the last slide, suggesting that with a bigger jump, with a bigger impulse, you'll have a bigger jump height. You can see this because of the strong and positive correlation on the scatter graph. And this shows that there is clearly a relationship between impulse and jump height, as each one is rising. So yeah, the bigger the impulse gets, the bigger the jump height is being recorded. And this is also shown between Charlie and Aaron, because Charlie has jumped at a bit higher impulse than Aaron, a much higher impulse, and he has also achieved a much higher jump than Aaron. This may actually shouldn't be made, because going back to the layups, they both achieved 1 layup each, and Charlie jumping up as high as he is and how tall he is, he really should be making more layups compared to Aaron, who doesn't even who's smaller and still is jumping a lot less than Charlie, and he still made the same amount of layups. So yeah, looking at the average jumps as well, Aaron jumped less than Charlie and less than the average, which shows how Aaron It's quite weird how he's made the same layups as Charlie, who looks like he can get definitely much closer to the basket. Moving on from the stretch reflex and the stretch shorten cycle. The stretch reflex basically acts like a spring in your knee. If you're testing for power, you would do the vertical jump test, and you bend your knee to power the jump and to quickly use the stretch reflex to full effectiveness. As you bend your knee, as a reactor to like stimuli, you will stretch your quadricep in this case for jumping, and you stretch the muscle spindle in your quadricep. And the muscle spindle sends an impulse to the spinal cord to cause a contraction in that stretch quadricep muscle that will revert the stretch. For stretch shortening, it's an active eccentric contraction stretch of a muscle followed by an immediate shortening concentric contraction of that same muscle. So this allows for a quick burst of power as it acts as a kind of an elastic band. The eccentric contraction of the muscle allows for energy to be stored in the muscle's elastic components. Then the quick concentric contraction quickly releases that stored energy, giving you an explosive burst of power. This is most important and common when testing for power, of course, and then participating in the vertical jump test. The stretch reflex and stretch shortening cycle, they're important in plyometric training as that consists of jumping. So to get distance with your jump, you need to get the quick and explosive power that these stretch reflex and the stretch shortening cycle can give you. So areas for improvement. 6.1 showed us that as Charlie is my main player, I've identified his weaknesses in the 6.1's performance criteria. He firstly ran 50 meters less than Aaron, which means that he's behind in play and is letting Aaron run on his own without being challenged, because they're both kind of experienced players compared to everyone else. This means that the rest of the team would have to work harder as Charlie hasn't covered the distance to attack or defend. To improve this, Charlie would just do 25-meter shuttle runs and do at least 10 repetitions with the limited rest, because you wouldn't be resting much in the game and you'd always be going up and down during the basketball game. You could add in skill activity at the end of each shuttle by making him have to do a rebound or a 2-point shot, just as a proper game-based skill. 6.1 also helped me identify how Charlie is moderately accurate with his free throws, but he doesn't get as many attempts as other power forwards like Aaron. This may suggest that Charlie isn't experienced enough to get into positions like Aaron does to get fouled and have a free attempt on scoring. To change this, he'll just have to maybe delay his shots and try and get into a position closer to the basket where he can get fouled. However, 6.1 also shows that Charlie has 100% accuracy at shooting 2 points, so maybe he feels stronger at shooting them whilst in play. Charlie's boxed out for 6.2. This is for area, sorry. Bang. Charlie's box out just suggests to me that his weaknesses was that he doesn't get low enough when he preparing for his rebound. This means that Charlie was more susceptible to being pushed over by the opposition. He should practice getting low with drills in training, try boxing out on his own without competing against an opponent. He could also then do squat box jumps, would help him build the strength and the muscle endurance in his quadriceps so he can get lower for a longer amount of time and keep his opponent away from the basket and the rebound. 6.2 also identified how Charlie didn't pivot when he had collected the ball. Usually you would pivot with your elbows out to warn the opposition off and to create the space to make the pass quickly and successfully. As Charlie didn't do this, the opposition could easily take advantage of him and quickly close him down so he could not make the pass. To rectify this, Charlie can just practice catching the ball, landing, pivoting with his elbows out, and try and get him so he can do this naturally in the game situation. 6.3 showed us that Charlie jumped higher than the average and also higher than Aaron, and this must mean that he takes advantage of the stretch and reflex stretch shortening cycle. This may be because he didn't get low when holding off his opponent. If he stayed low, he'd be in that position for longer, and the energy built up by the eccentric contraction would filter out, and he wouldn't have get more of that explosive drum. This may be why Aaron didn't get a higher jump, because he was in a lower position and he couldn't efficiently use the energy to built up by the eccentric contraction. This means that if Charlie would still want to get a high jump whilst having to get lower like he needs to for the perfect model, he'd have to maybe focus on some plyometric training, build up that power and speed in his knees, in his legs.